In this video, we're going to look at algebra and inequalities. So inequalities deal with the letters N, Z, and OR. We either do solid dots or we do non-solid dots and color them in, or not color them in, which will be for OR. So just a little build up to this question. We're asked to describe the set of natural numbers N, positive whole numbers. Counting numbers would also do. Positive whole numbers. If you don't know this, you need to go back and learn your number systems. Integers are as above, and negative whole numbers. So no decimals involved here. Or you could write positive and negative whole numbers. So graph the following inequality on the number line given. So the key to these is understanding less than or equal to, greater than, and greater than or equal to. For N and Z, we just color in dots. We do dots all the way along. And for OR, we put a circle around the solution and we either color it in if it's less than or equal to, or greater than or equal to. And we don't color it in if it's not less than or greater than or equal to. It's just less than or greater than. So that's the knowledge required. So X here is between -3 and 2. So the question is, do you color in -3? And because it's real numbers, we don't do the dots, we do the circle. X times of OR. So I put a circle around -3, I put a circle around +2, and I color in the line in between. There's all the real numbers in between +2 and -3. And because it's less than or equal to 2, I color this one in, and I leave this one not colored in to show that every number right up until -3, 2.99999 is included, and this is how it looks. Then we're asked to use algebra to solve this inequality. So the first thing I want to do is I want to take 8 away from everywhere. Just use the numbers first, -7, -8, and let's bring the 3g in. So I'm going to have on the left -15 less than -3g less than or equal to 11 minus 8, which is 3. Now the rule here, which I will explain, is if we have a negative that's less than, if we have a negative on the inequality and we want to make it positive, so I want to make 15, I want to make 3g, and this becomes -3, what happens is the inequalities change direction. Let's see why. -7 is less than -10. But if in algebra we can multiply across by -1 if we had an equal sign. Is 7 less than, sorry, I'm going to just change inequality. -7 is greater than -10. Is 7 greater than 10? No, it's less than. So if we multiply by -1, we have to reverse the sign of the inequality. This will be wrong. So now I'm going to divide by 3 to get 5. G and less than or equal to -1. So this is solving this inequality. This is one way to write it. Second question is the knowledge required is again from the first one. Write down an inequality in X represented by each of the number lines shown, and tick in the correct box in each case to show whether it's natural numbers, integers, or all real numbers, which are all the decimals in between. And the first one's done. We can see it's real numbers because of the circle not colored in and the circle colored in, and real numbers ticked for you. So because there's negatives in here, -3, this has to be Z. Can't be real, it's not colored in the line. This one here, 1, 2, 3, well this could be Z or N. I'm going to call it N because they're positive. And definitely the last one is real numbers again. So if I work my way back up, the last one, -2 and 4. X will be in the middle. And are they less than or equal to, or less than? And you can see because the circles are not colored in, we're just going to have less than for this one in here. Call number them 1, 2, 3. There's just not enough room in the box, I don't think. So this is number 3. Number 2. So we can say here for number 2, I think there's a couple of possible answers here for number 2. X will be less than or equal to 3. That would work, and X is an element of natural numbers, which we've called them natural numbers. You could also have X will be less than 4 and greater than, well, 0 or 0.5, maybe 0.5. That would also have numbers 1 to 3 in between, and that could be E, an element of Z or an element of N. And then number 1, I think this is the easiest one. I like this one the best. Number 1, they're integers and they have to be less than this number 2. So the 2 on the right, less than 2, and on the left hand side 3 is colored in, so this is not colored in, so we could say greater than -4. So x has to be between -4 and 2, and less than 2 and greater than -4, which we can see that it is for number 1. Maybe one more solution for number 1 would be x in the middle less than or equal to 1. 2 is not colored in, is it? No. And less than or equal to -3. But you can see that these two are the same for number 1. If there's no less than or equal to, we can't include the number that's colored in. So inequalities, get good at them, and it will be the easiest question you do on the exam. You can see why they're easy, because they don't really change. There's not much to them. The first one here, graph these following inequalities, x less than 4, and it's natural numbers. So the question you ask yourself, do I color in 4? Natural numbers, I can't go back any further than 1, and because it's not less than or equal to, I don't color in 4. So just 1, 2, and 3. X is less than 4, and it's an element of integers, so less than 4 can only be 3, 2, 1, 0, -1, -2, -3, -4, -5, and then I just put an arrow and I color it in to say it continues going in that direction. We can put the arrow anywhere along the line. I could put it at -1, I wouldn't need to color in the rest. And for the third one, we're dealing with real numbers. So I color in, I put a circle around 4. I don't color it in, and it's going all the way backwards this direction. We have the whole number line, so we may as well use it all. We'll put the arrow at the end, and it continues going all the way back in that direction. Do an arrow and color it in, and hopefully it looks a bit better than mine. Hopefully you're seeing more similarity between them. Complete the inequality in n below, not x this time, so that it has the solution set shown. So what would include 4, 3, and 2? Well, if we put a 4, it's less than or equal to, here I'm seeing for both, so we can put a 4 and a 2. X is an element of natural numbers, that will work. So with 2 less than or equal to n less than or equal to 4.6, say 4 would be the first natural number less than or equal to 4.6. Complete the inequality in x below, so there's only one possible value of x. And x is an element of the real number, so we can't have anything in between, so it doesn't matter what number you take. I like the number 13.1. 13.1, so that means that x has to be 13.1. There's only one possible answer. That's kind of what they're looking for here. This is very similar to one we saw earlier. We want to get rid of this 1 that's in here, so I'm going to take away 1 from each of the 3 sides. So I'm going to get -18 less than or equal to -3x. You know what happens. We're going to have to 13 minus 1 is 12, -18 -3x 12. We're going to have to reverse the symbols if we change the sign. So that goes that way and that goes that way. 12 becomes negative and 18 becomes positive. Dividing by 3, we'll get 6x and -4. This is exactly the same as if we bring the 4 to the left and change the direction of the sign. We get -4 less than x less than or equal to 6. And x is an element of integers, so color in 6, 5, 4 instead here. 3, 2, 1, 0, 1, 2, 3. And do we color in the -4? We don't, because it's not less than or equal to. So hopefully you're getting good at these by now. So repetition, the key in maths. What do I do here? I take away 3. I can do this in one step now. You've all seen this done. -5, I'm taking 3 from -2. I'm taking 3 from 3 to leave the 5x on its own. I'm taking 3 from 18 to get 15. Dividing by 5 to get -1 less than x less than or equal to 3. X is an element of real numbers, so do I colour in? I do, and I don't. I colour in because it's less than or equal to 3, and I don't colour in the 1, so it's all the numbers in between. So nice and simple. Okay, Neve is in a clothes shop and has a voucher she must use. The voucher gives a €10 reduction when more than 35 is spent. She also has 50 in cash, so she's 50 in cash and 10 off if she spends 35. Okay, write down an inequality in X to show the range of money she could spend in the shop. So Neve is in a clothes shop, just read it again, and she has a voucher which she must use, and the voucher gives €10 off. So when more than 35, so if she spends 35, she has to use the voucher, so she has to spend at least 35 to get the voucher. So take away 10, she'd only actually spend 25 of her cash, so that would be 25, and she could obviously spend a maximum 50 if she wanted. And an inequality in Y to show the price range of the articles she could buy. So the 25 cash she spent, she could spend 35 and get a tenner off. So she could buy something for 35, but she'd only be spending 25. And if something was 60, she could buy that as well because she'd get a tenner off. So she could buy something for 60 and she could buy something for 35. That's what they're looking for here. Notice anything about this question? It's very similar to before. We just have a fraction in it, so I'm going to multiply by 2 to get rid of the fraction. Minus 4 less than or equal to x minus 6. Be careful to multiply everything by 2, less than 2. Then I'm going to add 6. It might be handy to just write plus 6 underneath them all. Draw your line maybe if that helps. So I'm going to get 2 less than or equal to x less than 8. And that's it. I'm going to have a number line. Show the solution on a number line. So a number line real quick. 8, 7, 6, 5, 4, 3, 2, 1, 0. Obviously use a ruler in the exam, but not nowadays. You're kind of given the number lines. X is less than 8. It's a natural number, so we don't colour in 8. So we got to dot all the others. 7, 6, 5, 4, 3. And do I colour in 2? I do. I put a dot at 2 because it's less than or equal to. So if she saved 3,000 and wants to have 800 left, how much can she spend? 2,200. So she's 32 weeks, so she's going to spend, let's say 32. Let's imagine that it was 10. 32 times 10 would have to be less than the 2,200, but it's not. We don't know how much she's spending. It's just going to be X. So 32 times whatever she spends has to be less than 2,200, or actually less than or equal to 2,200. She could spend the max amount. And that actually is the next question. Find the max amount she can spend each week. She can't go out partying too much. So we just divide by 32. 2,200 over 32 gives me a total of, take your calculator out, 2,200 divided by 32. She has €68.75 to spend each week. About the average of what a Belvedere student spends in the ref each week.